Not anywhere special this week, just sitting back on my front porch with my kitties and my pumpkins. We're going to talk about rate of change in this lesson, so let's go ahead and get to it. Lesson 2C-3 is titled Slope and Rate of Change. And here's the thing about slope and rate of change. They're the same things. The only reason we have two separate names is kind of the context in which we use the different terminology. So our learning target for today is that we can find and interpret the rate of change of a linear function. Before we get into the notes, let's go ahead and pause the video and copy down these glossary terms. All right, so average rate of change is the change in value of a quantity by an amount of time. For a function, it's going to be the change in your y value divided by the change in your x value. The exact same thing is true of slope. It's the ratio, which means division, of the vertical change, which is your y value, and your horizontal change, which is your x value. So whether you're talking about slope or rate of change, it's always going to be your change in y over your change in x. All right, so let's get then to our notes. The rate of change, or the slope, there was a freebie for you, is a ratio describing how one quantity changes in relation to another. Like we said just now, we typically compare the outputs to the inputs. Remember, your outputs are your y values, your inputs are your x values. So it all is just a million different ways of saying the exact same thing. This is my y value, this is my x value. So when you write your rate of change, it's always going to be change in y over change in x. Linear functions have a constant rate of change. That's one of the things that makes them linear. When we graph it, it turns into a line because of that constant slope. So values increase or decrease at the same rate as your y changes. If the rate of change increases over time, so thinking about a graph, that would mean that as time goes on, your line is pointing upwards, we say that that rate of change is positive. So this line would have a positive slope. If, however, the rate of change decreases over time, so that would be, if here's my x-axis and here's my y-axis, if as my x gets bigger, my line is going down, so my y value is decreasing, that is a negative slope. So this is a positive rate of change or a positive slope. This is a negative rate of change or a negative slope. All right, so we're going to give you lots of different ways where you could try and find rate of change. Most of them you've probably seen before, but I'm going to show them to you anyways. One way that we can find rate of change is from a graph. So if I'm looking at a graph and they want to know the rate of change, I'm going to find 2 points that hit at nice, pretty intersections. So this one looks good to me, and this one looks good to me. Then to find the rate of change, remember I need the change in y, so change in y over the change in x. So to find my change in y, I'm starting at this point and I'm seeing how many points I have to go up before I'm at the same height as the second point. So from here I go up 1, 2, so it was positive 2 because I went up. So my change in y is 2. Then my change in x, to go from this line where we found our first point to my second point, I go over 1, 2, 3, 4, 5. Because I'm going to the right and moving towards the positive values on my x-axis, that is a positive 5. So then my change in x is positive. So that means that the slope of this line is 2 over 5. We can also find it from an equation. Remember that we have this formula, y equals mx plus b, in which the coefficient of my x serves as the slope. So when I look at this equation, all I have to do is find my coefficient of x, and I know that that's going to be the slope or the rate of change. So in this one, it's negative 4/3. Here, this one is written in standard form, not slope-intercept form. So in order to figure out the slope of it, we would need to solve for y. So we're going to subtract 3x from both sides. That goes to 0 and leaves me with just negative 2y. Over here, I cannot subtract those because they're not like terms, so I have 8 minus 3x. Now I'm going to divide by that -2 on every single term, and that leaves me with y. 8 over -2 is -4, and -3 divided by -2 is going to give me a decimal, so I'm going to leave it as a fraction, but I will take the time to say, because this is negative and negative, that becomes a positive 3/2 x. So that means that the slope or rate of change of this line, remember we're looking at our coefficient, is going to be 3/2, which would mean if I was on the coordinate plane for this line, I'm going to start at -4, and that means I'm going to go up 3 and over 2 before I hit that next point. Okay, so you can also find ordered pairs when you are, you can also find the slope or the rate of change when you're just given ordered pairs. But to do this, you need to use the slope formula. You should have seen this before in middle school. It can also be found on your formula sheet. These are attached to your mastery check desks, and you can also get a copy from us to keep in your notes if you'd like it. But this can be found, the formula is slope, which we use m to represent slope, both in our slope-intercept form and in this formula, is the change in y, so y2 minus y1, over the change in x, so x2 minus x1. So here's how this gets used. You'll be given two ordered pairs. We have a line that's going through the ordered pair 4, 2 and 6, 4. What you're going to do then is say, since this is my first point, I'm going to say that that is x1. I'm going to write it a little bit smaller. I'm going to say that this is x1 and this is y1, because every ordered pair is an x value and a y value, and since this is the first point, I'm making it x1 and y1. This ordered pair is my second ordered pair, so this is going to be x2 and y2. Remember, every ordered pair has an x value and a y value, so I'm making this my second x, this my second y. Now I'm just plugging into that formula. M is y2, which is 4, minus y1, y1 is 2. What that's going to do is tell me how much I've changed on the y-axis when I went from 2 to 4. On the denominator, I'm looking at x2 minus x1. So x2 is this 6, so that was my second x, and x1 is this 4, so 6 minus 4. And that's going to tell me how much I moved on my x-axis when I went from 4 to 6. Now I'm going to subtract each one. 4 minus 2 is 2, 6 minus 4 is 2, and then I can simplify that fraction. Do leave it in fraction form, because we typically talk about rate of change as that ratio of y to x. So leave it as a fraction unless it comes out to a nice pretty whole number like this one. 2 over 2 is 1. But always take the time to simplify that fraction at least. So my rate of change is 1. You can also find the rate of change from a table, and sometimes we'll give you a scenario to go along with that table and sometimes not. In this case, we said the average price for a ticket to a movie theater in North America for selected years is shown in the table below. Find the rate of change from 2009 to 2013. Well, go ahead and change that for me because that was a mistake. Let's say from 2010 to 2015. And then we also want to find the rate of change from 1995 to, let's change that to 2000. And then we're going to say, how do the rates of change compare? So we're going to do two problems and then write a little comparison statement. So remember that the formula for rate of change is y2 minus y1, or change in y, over x2 minus x1, or change in x. Before we get started using this formula, though, we need to figure out which of these values is going to be my x and which is going to be my y. Remember that your x value is your independent variable, which means it's the one that does not rely on the other value in order to change. So pretty much without fail, your time is going to be your independent variable. Unless you have a really good reason to think that it's dependent, assume that the year does not rely on the movie ticket price. So that makes this my dependent variable. So when I look at 2010 to 2015, my change in y is going to be 570 minus 540. My change in x is going to be 2015 minus 2010. 570 minus 540 is 30 cents. 2015 minus 2010 is 5. Now, normally I would tell you to put this in a fraction with no decimals, but when I divide this I get 0.06 or 6 hundredths. Remember though that we're talking about money, so what this tells me is that we have a change of 6 cents per year. So in the context of this problem, it makes more sense to write it this way than to write it as a fraction, because we're not really going to be using it as slope. Now, the second part of the problem wanted me to look at 1995 to 2000. So when I do that, I'm going to be looking at this change in y. So it's going to be 480 minus 450 over my change in x is going to be 2000 to 1995. When I do that subtraction, 480 minus 450 is 30. 2000 minus 1995 is 5. And when I do that division, I'm going to get the exact same thing, which is 6 cents per year. So when I write my comparison, I'm going to say that the rate of change was the same for both intervals of time, which means we can assuming that that rate of change stays the same across all of these, we would say that this is a linear relationship. All right, the last thing we're going to look at is sometimes when you're given a graph, it won't ask you for the rate of change for the entire line. It'll just ask about a specific interval, and oftentimes it'll use function notation to do so. So in this case, it wants to know what's the rate of change from f of 0 to f of 2. So that, remember, we've got f of x. So this is my x value. So when x is 0, that's here. And when x is 2, there's x2 on this line, that puts me right there. So my rate of change from f of 0 to f of 2 is going to be y2 minus y1 over x2 minus x1. My x values were given to me in the problem. It's 2 minus 0, because this is my x sub 1, and this would be my f of x sub 2. So the outputs that correspond to those, when f of 0, the outcome is 1 to negative 3. So I'm on my y-axis, I'm at negative 3, minus my y value at f of 0 is 1 to positive 3. So I'm just looking at what's the y value at these different x values and plugging them into my formula. Then I can say negative 3 minus 3 is negative 6, and 2 minus 0 is 2. When I simplify that fraction, I get negative 3 over 1, which we can just write as negative 3. The last thing we need to discuss are two special cases when we're dealing with slope. So these special cases are a horizontal line which has a slope of 0. These are equations like y equals 4. And the reason these have a slope of 0 is because if you think about two ordered pairs where y is 4, so 0, 4, and 3, 4, let's say. When I put these in my formula, I'm going to have my change in y over, which is x1, y1, x2, y2. So I put y2 minus y1 over x2 minus x1. And what that gets me is 0 over 3. Well, 0 over 3 is 0. And that's going to happen every single time you're dealing with a line that's y equals 4 or y equals 2 or anything like that. So when you plug those in, you're always going to end up with a 0 in the numerator. A vertical line is a line like x equals 2, and they have a slope that we say is undefined. When plugging points into into the formula, you are going to have a 0 in the denominator. So here's what that's going to look like. Let's say we have 3, oops, hold on. Let's say it says x equals 2. So let's stick with that and say we have the line 2 that goes through points 2, 3, and 2, 0, just to keep it similar. So this is x1 and y1, and this is x2 and y2. And my slope formula is y2 minus y1 over x2 minus x1. When I subtract that, I get negative 3 over 0. When you try and divide by 0, even if you put it in your calculator, you are going to get an error, and that is because that is an undefined value. We can't divide by 0. If you have trouble remembering that, when the slope is 0, when the slope is undefined, we have this little hoivu, or hoivux, however you want to pronounce it, that can help you remember. So basically it's just H is horizontal lines, 0 is slope, and the Y reminds you that those are your Y equals 4 or Y equals 2. The vux or vu, depending on if you're French or Southern, is vertical lines, undefined slope, and that comes from the X equals equation. So that's a nice little way to remember it. Hopefully it'll help you. Right, you do have some practice to do, and we tried to put some of each kind of problem. You also have an application, so make sure you get that before you start your mastery check. Good luck, guys.